Okay, so we are now in learning outcome 3. Okay, that is Fourier analysis. Okay, Fourier analysis. So this is a brand new topic actually. Okay. Okay. So so you know that up to here, up to this day, we have discussed time domain signal. No? We have discussed about time domain signal. Okay. So what is meant by a time domain signal? Can anyone tell? What is time domain signal means? Can anyone feedback, please? Simply, I hope you should, you should know the answer. What is time domain signal? What is meant by time domain signal? That is simply our independent variable is time. No? Independent variable is time. Okay. So that means we are, up to now, we are looking at the signal that is changing with time. Okay. So it may be a voltage or it may be a current. Okay. But it is changing with the time. Okay. So this is the time domain signal. This is a time domain signal. No? Okay. So if our independent variable is time, okay, we called it time domain signal. Okay. So tell me, what is the instrument we are using to see the time domain signal? In our labs, we have this equipment, instrument. What is that? Instrument. What is the instrument we are using to see the time, to see time domain signals? In our laboratories, we have many type of these instruments. What are they? Please tell me. What is the instrument? What is the instrument? It is oscilloscope, no? The instrument is oscilloscope. You have used these instruments, no? In our laboratory, we have two types of oscilloscope actually. One is cathode ray oscilloscope, and other is a digital oscilloscope. We called it digital storage oscilloscope. Okay. And actually, we have another oscilloscope, wide band oscilloscope. Okay. This is in optical lab. Okay. So mainly these two, you are working with these two very often, no? Am I right? I think in almost every lab you have to use this CRO DSO, no? Cathode ray oscilloscope or digital signal oscilloscope. Okay. Okay. Anyway, that is the instrument to see the time domain signal. Okay. Up to now, we were learning about this type of signal. Okay. So we have classified this time domain signal into several uh, signals. Okay, like periodic signal, non-periodic signal, odd signal, even signal, so on. Can you remember? Okay, periodic signal, non-periodic signal, and odd signal, even signal. So we have discussed many type of signals, no, under signal classification. Okay, so these are time domain signal. Okay, so these two will come to your mid-sem exam. Okay, this periodic signal and odd and even signal will come to your mid-sem exam. Okay. And also we have discussed some basic function. I hope you can remember we have learned about sinusoidal signal, sinusoidal function, and we have studied about the unit step function. We have studied about unit impulse function, and we have studies about exponential function, complex exponential function, like this. Okay. So under basic function, we have learned several type of several function, basic function, mainly sinusoidal signal, unit step function, unit impulse function, and complex exponential function. These four we have discussed. Okay. And also we have discussed about some time transformation techniques. No, so time is the independent variable. Okay, so we know that here we have the independent variable time, and we change this independent variable time transformation. Okay, so we called it time transformation. In under LO2 we have discussed about time transformation. That is also related with the time domain signal. Okay, that is also related with the time domain signal. And under time transformation, you have studied several techniques. Okay, and here you will get one question for mid-sem exam. Okay. Okay. So anyway, you can see that up to now we are dealing with time domain signal. Time domain signal. Okay. We have dealt with time domain signal up to now. Okay. Now we are going to see the signal in another way. Okay. We are going to see the signal in another way. Okay. That is from frequency. That is from frequency. Okay. So that means we are going to start our studies on frequency domain signal. Frequency domain signal. Okay. So mainly this analysis, frequency domain signal analysis, we are going to do with the Fourier analysis. Okay, Fourier analysis. Okay. So what is frequency domain signal? Can anyone tell what is frequency domain signal? I need your answers, okay? Please communicate with me, okay? I asked to communicate with me for your own good, okay? For your own benefits, okay? Please communicate with me. If you have done a mistake, I'm not going to care it, okay? You can talk with me, you can communicate with me. So if I tell you, if you have any doubt with these things, you can ask me or you can send me a chat, okay? So anyway, I want you to communicate with me, okay? So what is frequency domain signal? What is frequency domain signal? What is meant by frequency domain signal? Please tell me. Please tell me someone. You know time domain signal, okay? So please get the idea about the time domain signal and tell me what is the frequency domain signal. You can compare. Time domains means we are going to draw the signal with respect to time. So what is frequency domain signal? What is frequency domain? Please tell me. Please, someone tell me. Please tell me to proceed. Still, I didn't get any answer from you. Please don't be quiet. So what is Fourier? What is frequency domain? The graph? Yeah, thank you. Okay. Okay. Actually, thank you for your answer, and it is correct. Okay. The graph is based on the frequency. Okay. In time domain signal, the graph is based on time. Okay. Graph is based on time. In frequency domain, the graph is based on frequency. Okay. That is, we are going to draw our signal with respect to frequency. Okay. So that is the frequency domain signal. Okay. So here maybe, so you know that when we are dealing with the time domain signal, we draw our voltage or current or maybe power with respect to time. Okay. So this may be a voltage, current, or power. Okay. With respect to time. Okay. So in frequency domain, we do the same thing. No, we will represent, we will show, okay, the voltage or power. Actually, normally not current. We are not using the current. No, here also you can see that we most probably we have dealt with the voltage signal, not the current signal. Okay, because with the voltage we can analyze any circuit. Okay. Sometime if it is a current source or current related something, we normally convert it to the voltage. Then we will analyze it. Okay. For example, you know that if you have, so you know that there are some photodiodes in solar panel, no? Like this. It is a diode. Okay. So when the sunlight is put on here, it will generate a current. Okay, it will generate a current. Okay, actually it is a DC current like this. Okay, so this is a current actually. Time with current, ampere, value of ampere. You know that. Okay, in solar panel we are using this current, no? Okay, but when if you want to connect, if you want to, so normally if you want to charge a battery using this current, okay, you will not directly connect this current source to the battery, no? Okay, so here you will use another circuit. Normally we called it what is called it trans impedance amplifier. Okay, so you can please search if you want more details. Please Google what is trans impedance amplifier. You will get, it is a op-amp related circuit like this. Okay, so here the current, okay, here the current is converted to the voltage. Okay, and after that it is converted to voltage. We are dealing with this voltage, not with the current. Okay, so that is what I want to tell you. Okay, so in practically also, in practical aspect also, we like to deal with current, we like to deal with voltage rather than current. Okay, so that is the idea. Okay, so most probably we will use power, voltage or power signal. Okay, and here also most probably we will show voltage or power with respect to frequency. Okay, so do you have any problem up to now, up to here? Don't confuse with that things I have tell you. Okay, actually I like to tell you these things. I uh, I uh, I feel that you are more practical person rather than the theoretical students. Okay, that is why you can't you maybe you don't like to learn these theoretical things. Okay, that is why you choose this stream actually. That is my belief. Okay, So you like to do some practical things, okay? But if you want to do the practical things smartly, you have to learn the theories up to some extent, okay? So please do it. Okay, that is why I tell you the practical things whenever it possible, okay? So don't get confused with those, okay? This is a completely theoretical subject, okay? uh, if you see a paper, you can see it, no? Here we have just calculation, mathematics, and some theories, okay? But those theories are directly related with the practical work, okay? Okay, so do you have any question up to now, up to here? Okay, so I hope if you have any problem, you can ask, okay? If you have any doubt, you can ask, okay? Okay, so so that is that, okay? So now we are going to deal with this frequency domain signals, okay? So we will, so please get that idea, okay? So again, I will come to our topic, okay? So our topic is Fourier analysis. Fourier analysis, okay? Fourier analysis, okay? So at the beginning, I told you that our course mainly based on deterministic signal. Can you remember? Not with the random, not with the random signals, okay? Deterministic signal, deterministic signal, and also they will be continuous time signal, okay? Continuous time signal, okay? So in this course, signal and system 1, you will learn the Fourier analysis of deterministic signal, continuous time signal, okay? Mama, mama චුට්ටයි call එකක් දෙන්න. හරි 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 සම්බුල. අරක බලා ගන්න පුළුවන් මම බල්ලා කියන්නම්. හරි. Okay. So we here also we will deal with continuous time deterministic signal, okay? So our Fourier analysis will based on continuous time deterministic signal, okay? We are not going to deal with random signal or discrete time signal, okay? So if you consider this Fourier analysis, okay, so actually here you there is a history for this Fourier analysis, okay? It is introduced by the scientist called, I can't remember his name. I think he's anyway. He has the Fourier part. He had his name has the Fourier parts. I can't remember the complete name. Okay, so if you want to see it if you want to get, if you want to know the more details about the history of this Fourier analysis, you can refer our textbook. Okay. Okay. I think this guy, Joseph Fourier, no? Jean Baptiste, I can't read his name. Okay. So it is Fourier, no? Okay. So this scientist has first give the idea about the Fourier analysis. Okay. So you can go, you can read this stuff if you want. I'm sure you will not read these things. Okay. So I'm not going to tell you to read them. Okay. Anyway, it is around, the first publication is around 1822, no? 17 සතවර්ෂයේ නේ. Okay. So this is the history. Okay. So there is a history related with this Fourier analysis. Okay. So this Jean Fourier. Okay. Joseph Fourier. Joseph Fourier is the father of this Fourier analysis. Okay. And this is very powerful tool. Okay. This is very powerful tool for so Mihiranga, you need any verification or clarification, or maybe it's a mistake, no? You have sent a chat. Okay, you have sent a chat message. I hope it is a mistake. Okay, so if you have any concern, please put it to the chat, or please ask me directly. Okay, no issue. So this is the history. Okay, so we will not bother about the history. Okay, so we will directly see the Fourier analysis. Okay, so this Fourier analysis is very powerful tool. Okay, this very powerful tool. So you can see that in the history, maybe if you noted, there are some pictures related with the water pattern or something, no? Okay, so you can see that this tool not only applicable for voltage and power related things, that means this is not limited to electronics, electrical or electronic communication domain. Okay, we are in this domain. Okay, we are in this domain. I think all the students are electronics students, no? No any mechanical or other stream students. Okay, all are in electronic stream. Okay, so you can, if you have noted, you can see that this Fourier analysis is not limited to electronic or electrical or electronic communication domain. Okay, and it is also applicable for other engineering domain, maybe civil engineering, mechanical engineering, okay, hydraulic engineering. Okay, in many cases, this Fourier analysis is a very powerful tool. Okay. Okay, so if we are talking about the Fourier analysis, okay, okay, so already I told you that we are mainly concerned with the continuous time signal. Okay, and also we will going to analyze periodic signal using the continuous time periodic signal using Fourier analysis, and also continuous time non-periodic signal using Fourier analysis. Okay, so mainly we are hope to discuss these two aspects. Okay, I can't remember, maybe in this course we are not going to learn about the non-periodic signal, continuous time non-periodic signal. We are not going to learn. Okay, I think it is in signal and system 2. In next semester you have to do this subject also, no? Signal and system 2. Okay, so there you will learn continuous time non-periodic signal analysis using Fourier analysis. Okay, and in this course we are mainly focused on continuous time periodic signal. Okay, continuous time periodic signal analysis using this Fourier tool. Okay, so Fourier analysis can be mainly divided into periodic signals analysis and non-periodic signal analysis. In this course, we are mainly focused on periodic signal analysis. Okay, so I hope you get it. Okay, so actually, when we are dealing with the continuous time periodic signal, we called it Fourier series. Okay, Fourier series. Fourier series. And also we called it Fourier series representation, maybe. Okay, and if we are dealing with the non-periodic signal, we normally called it Fourier transform. Okay, we normally called it Fourier transform. So in this course, we are mainly focused on Fourier series representation. Okay, so we are mainly going to talk about Fourier series representation. Okay, Fourier series representation. Okay, so actually this is our topic and this is our LO3. Okay, so that means we are going to analyze continuous time periodic signal. Okay, continuous time periodic signal using Fourier analysis. Okay, so we are talking about many words: Fourier analysis, Fourier series, Fourier transform, so on. Okay, and our topic is Fourier series representation. Okay, so this is under Fourier analysis. Okay, and we are mainly do this Fourier series representation. Okay, so any problem up to now? So this is a brand new one. Okay, so we will go slowly. Okay, we will move so slowly and we will try to understand the things slowly. Okay, so anyway, do you have any concern about this? Do you have any doubt up to this? So I hope you have not. Okay, so we will move. Okay, we will move forward. Okay, so our topic is Fourier series representation. Okay, so I hope now you have idea about this. Okay, so how to start? Okay, okay, so let me take arbitrary. Before discussing the Fourier series representation, I will remind you one thing. Okay, can you remember that? Okay, if you have any arbitrary signal, like this, okay, so this is a time domain signal. Okay, can you remember that? So anyway, we have learned about 4 basic functions. Can you remember? One is sinusoidal function, a cos omega naught t plus phi. Okay, this is a sinusoidal signal. And also we have learned about unit step signal. Okay, and also we have learned about shifted unit step signal. Can you remember? I hope you can remember these things. Okay, and also we have learned that the unit impulse signal and also shifted unit impulse signal. Okay, and we have learned this signals also, and also we have learned complex exponential signal. Okay, so this is a complex exponential signal. So these 4 signals we have learned. Okay, and if you can remember that, if you can remember this too. Okay, so let me take this sinusoidal signal here. So this is our sinusoidal signal, a cos omega naught t plus theta. This it is in this form. I hope you can remember. Okay, so can you remember that these two are periodic signal? These two are periodic signal, and these two are not periodic signal. These are non-periodic signal. Can you remember that? Okay, so these are periodic signal, and this is non-periodic signal. These two are non-periodic signal. Okay, and also we have found the period. Okay, we represent this. We represent this as omega naught t. Okay, ej omega naught t, and the period is fundamental period is 2 by omega naught. Okay, and here also fundamental period is 2 by omega naught. Okay, so these are periodic signal. These two are periodic signal. This sinusoidal signal and complex exponential signal. Complex exponential signal and this sinusoidal signal. These are periodic signal, and this unit step signal and unit impulse signals are non-periodic signal. Okay, I hope you can remember. If you can't remember, please go through the lectures we have done. Okay, okay, and I think there is some Fourier series in Sinhala language also. Okay, you can refer these internet resources to get the idea. Okay, so there are many resources actually. Okay, so there are many resources. Okay, so here also some videos are in Sinhala. Okay, so maybe in Tamil language also maybe they are. Okay, so if you are not comfortable with the language, you can refer them. Okay, so and here one animation things. Okay, so after doing up to some extent, we will see this animation also. Okay, so you can see that here we have many resources in YouTube under Fourier series. Okay, and if you want to learn about, if you want to memorize the basic signal. Okay, so here this lecture I have uploaded. You can refer this lecture. Okay, so there I have discussed the basic signal. you can see that unit step signal, unit impulse signal, and complex exponential signal. We have discussed these three, and I think in later uh, previous with the previous lectures, I have discussed the sinusoidal signal also. Okay. Yeah. Here we have talk about sinusoidal signal. Okay. So you can see this lecture also. Okay. So this is related with the sinusoidal signal. Okay, and I have uploaded these things to the LMS. Okay. Where is that? Yeah, this one. Okay. This one and this one related with the sinusoidal signal. Okay, you can refer this to lectures, and also you can refer this lecture to get a recap about this four type of basic questions, basic function. Okay. Okay. So what I want to uh, tell you is that can you remember that this kind of signal we can approximate to a step signal like this. Can you remember? We have discussed this. Okay, in our lectures we have discussed this. Like this, we can approximate this arbitrary signal. Okay, so now this is a step signal. Okay, so if you have a step signal like this, okay, okay, so this signal can be represented using this unit step function. Okay, so using this basic function, you can represent this unit step, this step function. Okay, and any function uh, we can approximate to a step function like this. Okay, so what is the idea there? Okay, so you can see that any function, okay, any function can be approximate to unit step function, and any, sorry, approximates to step function, steps function. So step function means there are step like this. Okay, so this is a step function. Okay, so there are step. Okay, and any step function can be converted, can be written with unit step function, and shifted unit step function. Okay, so what is the idea? Any function can be represented through unit step function, no? Unit shifted unit step function. Am I right? So do you have any issue? Can you understand up to here? Still, we are not talking about the Fourier series. Okay, we are talking about the old things we have learned. Okay. Okay. So if you follow my lectures, or if you try to answer the, if you try to find the answer to that two tutorials, definitely you should aware of these things. Okay. Okay, so do you have any concern? up to this? Okay, you can see that any function, any arbitrary function, we can represent with unit step function. Okay, unit step function and shifted unit step function. That is the idea, and this is we have done previously. Okay, I hope I have done some example also. Okay, you can refer the lectures, you can refer the LMS page. Okay, I have done one or two examples also, and in tutorial also you will have one example, no? Can you remember? If you have done this, you, oh, sorry, this is tutorial 2, no? It is tutorial 1. Tutorial 1. Discussion. So if you have done discussion, or if you try to do discussion, okay, these are not new things. Okay, these are not new things. Okay, so I hope one or two sample also I have done by myself. Okay, anyway, so this is that. Okay, okay, so what is the idea here? You should get the idea is that any function, any signal can be represented using this unit step signal. Okay, so how it related with the Fourier series actually? Okay, so we know that. Okay, so this is very important point, and it is a new point. Okay, so like any signal can be represented using unit step or shifted unit step function as a combination of unit step and unit shifted unit step function. Okay, we can represent any, actually not any, okay, almost all, almost all practical one. Okay, we can represent, you can use this word, but it is not 100% correct. Okay, but you can use this any words. Okay, so I will use it. We can represent any periodic signal, okay, as a combination of sinusoidal signal or complex exponential signal. Exponential signal. Okay, so read this statement again by yourself. Okay, we can represent any, okay, this is not 100% correct, but this stage you can use this. We can represent any signal, any periodic signal, okay, as a combination of sinusoidal signal or complex exponential signal. Okay, like this. Okay, like this. Okay, so this is actually Fourier series representation. This is actually Fourier series representation. Okay, did you get it? This is actually Fourier series representation. What is Fourier series representation? Tell me someone. What is Fourier series representation? What is Fourier series representation? This one, you can read this statement. Okay, this is the Fourier series representation. This is meant by Fourier series representation. We can represent any periodic signal as a combination of sinusoidal signal or complex exponential signal. Okay, so if you consider the Fourier series representation, how many representation you will have? Can anyone tell me? Please tell me. Do some analyze. Do an analytical thing here. Okay. So tell me how many representation we will have. If you're going to represent a signal as a Fourier series representation, that means how many representation you will have. Tell me, please. Tell me. So answer is here, okay? Answer is here, okay? Answer is in this page. Tell me the answer. How many representation we will have? Tell me. Yeah, please tell me. Please don't waste the time. The answer is here in this page. Are you with me? So what is? Okay. So how many representation we will have? We will have two representation. How many means I ask the number. Okay, I have draw. I have divided this into two. Fourier series representation into two. Okay, and also I have tell that we can represent, we can write any signal, any periodic signal as a combination of sinusoidal signal or complex exponential signal. Okay. So you can see that we will have two representation. Okay. One thing is this using this sinusoidal signal. Okay. So the answer is 2 actually. Okay. We will have two Fourier series representation. Okay. We will have two Fourier series representation. Okay. So one is using this complex exponential signal. Okay. So we called it complex exponential Fourier series representation. Fourier series representation. Oh, can anyone give a name for other one? So if we are representing any signal as a combination of complex exponential signals, it is called complex exponential Fourier series representation. Okay. And also we can represent any sinusoidal signal as a combination of sinusoidal signal. It is called sinusoidal representation, sinusoidal Fourier representation. Can we suggest this name? Yeah, we can suggest, but formally it is said that trigonometric, trigonometric, the trigonometric, trigonometric, anyway, I pronounce it as trigonometric. Okay. Trigonometric Fourier series representation. Okay. So we will have two type of Fourier series representation: complex exponential Fourier series representation and trigonometric Fourier series representation. Okay. And this complex exponential Fourier series is the vastly used representation. Okay. We can't say it is vastly used one, but this is simplest one. Okay. This is the simplest one. Okay. And this is somewhat difficult, but it is not very difficult. This is somewhat difficult. Okay. So sometime maybe we are mainly dealing with complex exponential Fourier series. Okay. Okay. So did you get it? Did you get it? Do you have any problem? Anything? So what is we are talking up to here? We see that Fourier analysis is very powerful tool. Fourier analysis. Okay. Under Fourier analysis, we are going to deal with periodic signal. Periodic signal. We called it Fourier series representation. Fourier series representation. And we have two type of representation. One is complex exponential Fourier series representation, and the other one is trigonometric Fourier series representation. So this is the summary. Okay. So this is the summary. Okay. So I hope you get it. If you have any problem, you can ask. So I know that you may not understand the things very well. Okay. But please stay with me and try to understand this. I like if you ask question, okay, then we can discuss actually. Okay. So anyway, uh, so this is the thing. Okay. Okay. So if you have any signal, if you have any periodic signal, okay, so someone tell me what is the common property of this complex exponential Fourier series, complex exponential signal and trigonometric, sorry, what is the, so here in complex exponential Fourier series, we are going to represent the signal as a combination of complex exponential signal. Okay, as a combination of complex exponential signal. Okay, and uh, in trigonometric Fourier series, we are going to, so this is as a collection of complex exponential signal. Okay, as a collection of complex exponential signal and in complex exponential Fourier series representation. And in trigonometric Fourier series representation, we are going to represent the signal as a combination of sinusoidal signal. So basically we have learned two sinusoidal signal, that is sine signal and cos signal. Okay, so we can represent any signal as a combination of sine terms and cos terms. Okay. Okay. So actually this is the idea. Okay. So tell me, in complex exponential Fourier series, we are going to represent it using the complex exponential signal. Okay, complex exponential signal. And in trigonometric Fourier series case, Fourier series representation case, we are going to represent it as a sum of sine and cosine signal. Okay, sinusoidal signal. Okay, so tell me what is the common property of these two signals, complex exponential signal and sinusoidal signal? What is the common property? Before 5 or 10 minutes, I give the answer. I told you the answer. Okay. If someone can tell me this this answer, okay, I will mark it and I will add 10 marks to his or her paper, mid-sem exam paper. Okay. So please tell me the answer. What is the common property of complex exponential signal and sinusoidal signal? I will give you 5 minutes. Okay. If you give me the correct answer, I will add 10 marks to your mid-sem exam. Please get this opportunity. Okay, this is not a joke actually. Definitely I will add. So tell me, just now I have tell you. Yeah, I tell you. When I explain this for signal, I tell you what is the common property. What is the common property? Okay, time is over. Okay, so I think still you have 2 minutes, around 2 minutes. You can if you can tell me the answer. Yeah, it is continuous time signal. Okay, I will add some marks, but this is not the answer I expected. Okay, anyway, I will mark and I will add some marks to your paper. Okay, definitely I will add this one. So I hope, can you tell me your registration number, please? Because normally I handle the mark with the registration number. The student one who gave me the answer, can you, okay, thank you. Okay, anyway, thank you for this answer. Okay, that means you are with me. Okay, you are with my lecture. Okay. Okay, the answer is that I have here I have explained. Can you remember that I have explained that? Sorry, I have explained this complex exponential and sinusoidal both are periodic signal. Periodic signal. Okay, both are periodic signal, and the period is 2π by omega naught. Can you remember? Here I have these are periodic signal. These are periodic, and the period is 2π by omega naught. Okay. So anyway, so you can see there is some what is called, there is a connection. No? So here we are going to represent periodic signal with as a combination of, these are basic signal. Okay, these are basic signal. So these are fundamental signal as a combination of basic periodic signal. Okay, so that is the idea you should get. Okay. Okay, so we can represent any signal xt, let's say xt, any signal, any periodic signal. Okay, any periodic signal. Okay, let's say the period is omega naught here. Okay, not the period, this is fundamental angular frequency. No, can anyone remember the relationship between omega naught and t, the fundamental period? Okay, okay. So anyway, this is a periodic signal. Okay, this is a periodic signal. Okay, and let's say the fundamental period is t naught, not omega naught. Sorry. Okay, t naught. Okay, t naught. Let's say the fundamental period is t naught. Okay, and this can be represented as a sum of complex exponential signal like this. Okay, so this k will be an integer value. It is going to minus to plus infinity. Okay. Okay. So actually this is the Fourier series representation, complex exponential Fourier series representation. Okay. So this is the complex exponential Fourier series representation. Okay. And here there is what is called, there is what is this called, coefficients, Ck. Okay, there is a coefficients also here, Ck. Okay, and this Ck can be calculated using an integral. Okay, xt e to the power minus jk omega naught t et. Okay, so this is the Fourier series representation. Okay. These two identity. Okay, so this k is integer. Okay, so that may be minus infinity to plus infinity, including 0, maybe -1, -2 up to infinity, and +1, +2, +3 up to infinity. Okay, so this k is an integer value. Okay, so this Ck is given by this integral, and this integral should be done within one period. Okay, so this is the Fourier series representation, complex exponential Fourier series representation. Okay, so we will do only this one. Okay, we will do only this one, and we will do some example. Okay, maybe before next class discussion, maybe I will be able to record some example how to use this identities, okay, to represent the periodic signal. Okay, then you can see them and you can get the idea. Okay, so anyway, remember these two identities. Okay, let's see the our textbook also, because maybe let's take Chapon. So you can see that chapter 5 is Fourier analysis of continuous time system. Okay, so our focus will be on this chapter. Okay, so you can refer this chapter also. Okay, so you can see some introduction is there. Okay, so you can see that here we convert time domain signal into frequency domain. Okay, representation. Okay, so this is the idea of the Fourier analysis. Okay, and this is what we are doing now, Fourier series representation of periodic signal. Okay, and I think you can remember this too also. This is the condition for periodic signal. Okay, and these two are our fundamental signal, basic periodic signals, sinusoidal signal and the complex exponential signal. Okay, and using these two basic periodic signal, we can represent any signal xt minus infinity plus infinity ck e to the power jk omega naught t. Okay, so omega naught t is equal to 2 phi by t naught. Okay, and ck can be, this is the coefficients, that coefficients can be estimated using this integral. Okay, okay, and the zeroth coefficients can be evaluated using this identity also. Okay, so we will do some question related with this. Okay, so I think I have write the correct form, no? Ck e to the power jk omega naught t 1 by t naught within t naught xt e to the power minus jk omega naught t. Okay, so this is the Fourier complex exponential Fourier series representation. Okay, I will do some questions related with this, and you will get understand. Okay, so actually we will use this these two or three identities within our whole LO3 content. Okay, so any question up to now? Okay, if you don't have any question, okay, we will stop here. So we have started new topic, Fourier analysis. Under Fourier analysis, we are going to analyze uh, periodic signal. Okay, so we called it Fourier series representation. Okay, so under Fourier representation, there are two type of representation. One is trigonometric representation, and other thing is complex exponential representation. Okay, and we will choose the complex exponential Fourier uh, representation. Okay, and this is the identity. Okay, these are the identities used in complex exponential Fourier series representation. Okay, so if you don't have any question, we will stop. But uh, if you can, if you like, you can wait another. I will again. I will log around uh, five five within 5 minutes. I will again connect, and I will do one I will do this example. Okay, I will do this example. So this kind of question will come to your mid semester exam paper. Okay, so I hope to do this example. Okay, not this example actually. I think I have done this example. This is to find the odd and even parts. Okay, so I am going to do one question in tutorial 2. Okay, not tutorial 1. Okay, so I will do this question. I will do this question. Okay, so I will start it 5 past 5. Around after 5 minutes, I will start doing this example. This kind of example will come to your mid-sem exam. Okay, so if anyone interested, you can wait here. Anyway, I will upload the lecture to the LMS, maybe not today. Okay, tomorrow may be possible. So anyway, I will do this question. So if you can't do this, so if you want to stay, you can stay. Within 5 minutes, I will start this. Okay, anyway, you can leave, no issue. Okay, if you are interested, you can wait. Okay, if you are not tired, you can wait. Okay, otherwise you can leave. Okay, anyway, thank you for joining. Okay, so anyway, I will do this question after 5 minutes. Then I will stop the